Right, so if I asked you, what's the current that flows through the battery? Okay, so now, if the current that leaves, if we were trying to find the current through the battery, well, do I even know the whole resistance? No, but I know that V is equal to IR. So if I have the voltage of the battery, if I had the whole resistance that's applied to that battery, could I find the current through the battery? Yeah. So first what we have to do is combine these into an equivalent resistance. Do you remember in math when you learned how to multiply stuff and it was like 6 minus 8 times 4 plus 2 times 7 divided by 12, like that? Okay. Did you start with like 6 minus 8? Is that where you started? No, where would you start? You start with like on the inside and you work your way out. I think of circuits with resistors in parallel and series as being sort of like that same parentheses math business. Okay? All right, so we're going to start on the inside. And when I look at this, I see this inside as being like where the 4 ohm resistor and the 4 ohm resistor, doesn't that kind of look like the parentheses part? I'm going to start with that first. So how are those two resistors wired? Are they in series with each other or parallel? They're parallel. Okay. So then I'll have 1 over the equivalent resistance of that parallel branch is equal to 1 divided by 4 plus 1 divided by 4. Now I picked nice numbers so that they would have common denominators already. So that's what, 2/4? But please use your calculators. Don't spend time getting a common denominator for something that's not straight up easy. Okay? So now what's the equivalent resistance of that parallel pair? It's 2. 1 over the equivalent resistance is equal to 2/4. So the equivalent resistance is 4 halves, or 2 ohms. Most common mistake of all time with parallel resistors. Okay, so that means that I could redraw this circuit. And this was, yes, the total parallel resistance is 2. If they're in parallel, yes, you have to set them up as reciprocals. So now this 6 ohm resistor remains, and I can pull out those 2 4s and replace it with a 2 ohm resistor, and I'll have the same net effect. So I found that the 1 resistor I could pull out, or could replace the 4 ohm resistors in parallel with each other with a 2 ohm resistor. So now how are those wired with each other? They're in series. And how do we add resistors in series? You add them up. So the equivalent resistance of those would be 6 plus 2, which is 8 ohms. So now we've got a battery effectively wired to a 16 ohm or 16 volt battery wired to an 18 ohm resistor. I said the wrong numbers. I'm so sorry. This is 8 and this one is 16, right? Okay. So what's the current through the resistor then? How'd you get that? V equals IR. So 16 is equal to I times 8. I is 2 amps. Okay, so that's the current that leaves the battery. Okay, so that's the current that goes through this 8 ohm resistor. But was it really an 8 ohm resistor? No, it was really one step further. Oh, it was really a 6 ohm resistor and a 2 ohm resistor, right? Okay, so what's the voltage then across this 6 ohm resistor? V equals IR, so the voltage is 12. And if V equals IR, then what's the voltage across this guy? 4. What's 12 plus 4? 16. Oh, does that equal the voltage that we started with? How about that? Oh, now this really wasn't a 2 ohm resistor, was it? No, it was really like a 4 and a 4, so let's back up one more step. So we had 2 amps right here. What's going to happen to this 2 amp current if it can split up between a 4 and a 4? It's going to split